Azure Site Recovery stuff today, and giving you a kind of a run through of how it works and everything. So if you could now turn your attention to him, and he's going to take over.
Thanks, Chelsea. Good afternoon, everyone. As Chelsea said, I'm Joe Migliori, Chief Technical Architect for the Infrastructure Practice here at B2B Technologies. We have a strong focus on Microsoft Cloud Solutions. We're a Microsoft Elite Windows Azure Circle Partner, which is the highest level of the Microsoft Cloud Accelerate Partner Program. So again, thanks for joining us today. Just a quick agenda. We're going to be going over Azure Site Recovery, real quickly, the Business Continuity Challenge. We'll dive into some of the Azure Site Recovery capabilities. We'll go through configuration of ASR within Azure, as well as doing an actual failover demo of a VM to the Azure Cloud. So why do businesses need a robust BCDR solution? So outages, according to the survey, 4+ disruptions per year. Recovery times can range from 1 to 9 hours. These costs of disruptions can be very high, as we know. Too many businesses would not be able to recover after a major disaster. Another cost of an outage, which I think a lot of folks maybe don't consider, is, and it's a little more difficult to determine, is in the brand and the equity of the organization. So the loss of reputation and customer trust that can be severely impacted or sometimes irreparable. And another big driver for BCDR solutions that we're seeing with our clients is to meet some requirements from a partner organization, as well as for some other regulatory compliances. So some challenges to the more traditional DR solutions that we've seen in the past, some roadblocks to implement. A lot of solutions are overly complex. They require an in-depth knowledge of the actual application being protected. For example, if you wanted to leverage built-in application high availability options such as an Exchange database availability group or a SQL always-on availability group, that's typically going to involve the input and time of a highly specialized technical resource, not only to design and implement it, but to support it going forward. Another challenge that we're facing IT administrators is that the data is growing exponentially. So our legacy DR solutions providing DR, they grow in a more linear fashion, so they become obsolete as these data sets outgrow those legacy solutions. Another roadblock is the long data retention requirements when designing the BCDR solution, and that's again going to be exacerbated by the growing amounts of data that we're seeing. A lot of legacy solutions are going to involve media management, and that's extremely time intensive, and again, those only expand out linearly while our data sets are continuing to grow exponentially. Legacy DR plans are historically difficult and expensive to test. They require the coordination of multiple highly skilled employees to execute typically, as well as it could require some planned downtimes while we're doing this DR testing. And this results in less frequent testing. It leads to a decrease in confidence of recovery plans being successful as well. And then the increasing costs of providing BCDR solutions as data sizes and the number of VMs increase is also a challenge that's facing IT departments. So what are our goals of a disaster recovery implementation? So the basic functionality of any solution is orchestrating the recovery of applications. It should be repeatable, it should be reliable, and it should simplify the disaster recovery process. So the solution should improve recovery time objectives, as well as recovery point objectives for both planned and unplanned outages. And when we say unplanned outages, a lot of folks might think of BCDR as simply for unplanned outages, but when we talk about planned outages, we can use that, we can actually leverage our DR solution for things that are not catastrophic in nature. So as an example, we've had a client who's a customer who was a Major League Baseball team. They were housed as primary data center in a ballpark. When their new ballpark was built, we were able to leverage their BCDR solution to fail over all of their essential systems to their DR data center for an extended period, while they then physically moved their primary computing environment to the new ballpark. And then after the move, we were then able to utilize the BCDR solution to fail their migrated systems to the primary data center, the new primary data center, and again, able to do that all with minimal downtime and zero loss of data. So another goal of a DR solution is going to be being able to have disaster recovery drills and being able to test the failover of our recovery plan without impacting our production environment. One thing that comes up a lot when we're working with our clients is that they're utilizing some sort of array-based snapshot technology, and to this next bullet point, the minimize app errors and data loss with application-consistent recovery points. A lot of the snapshotting technologies that we see out there having to do with storage array networks are not actually application-consistent recovery points, and this comes up when we're doing our DR implementations because they're not able to test the recovery of those snapshots. Typically, it's time intensive and it can be a little bit impactful. So one thing that comes up when we're doing these implementations is that they find that their snapshots are actually crash consistent, and that can actually result in things like SQL databases coming up dirty or not able to mount, things like that. So when we're talking about our DR solution that we want to use, we want to make sure that we're getting application consistent recovery points, that we can fully recover our applications in the event of a DR scenario. Another goal of a good DR solution is replication for heterogeneous environments. So we now have capability in these more robust solutions to replicate and protect Hyper-V, VMware, as well as physical servers, and that's something that's pretty new. And also our solution, we want it to be flexible so that we can leverage our public as well as private infrastructures for recovery as everybody's moving more towards a hybrid cloud. So this is a pretty well-known slide for anyone who's seen an Azure demo. It summarizes Azure's value to its customers. So in the context of ASR, I really see like three immediate values, which illustrates Azure's commitment to empowering businesses. Number one is obvious in the title, it's recovery. This is for planned and unplanned events in an orchestrated fashion. Today that is Hyper-V, it's VMware, as well as physical servers. A less well-known feature of ASR is that it provides the capability to recover to either Azure or to the customer's own DR site. And we'll go through some of the scenarios here in the next slide. The second thing I see is that you can leverage ASR for migrations to move from on-prem to Azure. So taking the solution a step further, we're not just doing protection, but we can actually allow replication of our VMs, no downtime, and then actually fail over and move those workloads to Azure with minimal downtime during the actual failover. So it's kind of a cool way to use the solution. And this does allow for failing back to on-premise if necessary. And then the third thing I would probably mention is their dev and test capabilities. So with ASR, we can replicate our production VMs to an isolated environment in Azure, and then fire up those virtual machines, those workloads in Azure to perform development and testing. So not just for DR, but we can actually take a slice of real production systems using real data. We can put that into an isolated environment in Azure very easily, which we'll actually see in the demo later, and then do our development testing. We can test upgrades. We can look at root cause analysis, any things you can do with that. So as we just talked about, ASR provides a single solution for protecting as well as recovering heterogeneous environments. They can leverage the public and private infrastructures as recovery targets. So number one, in our scenario here, this includes Hyper-V to Hyper-V on-premise. That's actually going to leverage Hyper-V replication for the replication mechanism. The second scenario is kind of a recent addition, and this is the ability to perform Hyper-V to Hyper-V targeting, but actually leveraging SAN replication. So this would be on-premise again, but instead of using Hyper-V replication, we've got hooks into the storage area networks, and we actually rely on that replication to basically to piggyback for the ASR recovery plans. The third one is a pretty common scenario, and that's Hyper-V to Azure. That's what we'll be looking at today for the demo. And that's actually using the InMod's replication engine that Microsoft purchased. I think it's been a couple years now. So number four, this is another, it's less well-known capability. and that's the ability to actually replicate VMware VMs or physical servers to an on-premise VMware target. So using Microsoft Azure. So that's interesting, or Azure Site Recovery, I should say. And then the fifth scenario here, ASR is capable of protecting VMware as well as physical systems out to the Azure cloud. Any questions on that before we move forward? I know there's a lot to take in, but all right, moving on. So let's take a closer look at how ASR communication works in those different scenarios we've discussed. On the left here is an on-prem Hyper-V site to Hyper-V, both on-premise, in which the replication channel is either Hyper-V replica or the SAN replication. This has the ability to target another on-prem Hyper-V environment. While the data is replicated to the recovery environment, the metadata or the recovery plans, things like that, are actually stored in the ASR vault in Azure. So the illustration on the right is going to show VMware and physical server protection to another on-premise VMware environment. And this actually leverages the InMoj replication for the replication as well as the orchestration channel. It's the technology Microsoft purchased, and that's kind of the heart of providing capabilities for protecting these heterogeneous environments. So here we see the capability of Hyper-V or a VMM site to protect to Azure as a failover site. And similar to the on-prem scenario, the metadata is kept in the ASR vault, which we'll see in a few minutes, but the replicated data is actually kept in Azure storage. So the data actually never goes to the ASR vault. It's still retained in Azure storage like any of your other data sets within Azure. And then once again on the right, this is the VMware physical replication and the orchestration leveraging the InMoj technology, and that's replicating out to the Azure Site Recovery in that scenario. Right, so ASR in the VMware and the physical server scenarios, it has a few extra components to function. One is going to be the process server. That's the gateway that resides at the primary site. That handles all the compute and all the I/O-intensive aspects of replication. That's deployed on a physical or virtual machine running server 2012 R2. It's responsible for receiving data changes from the primary workloads. It performs compression, encryption, caching, bandwidth management, things like that, before replicating to the secondary location. So this approach offloads all those compute and I/O-intensive tasks that are involved in continuous replication to the process server, and that eliminates almost all the overhead on the protected workloads themselves. The config server we see here is the role that runs at the secondary site. This is responsible for maintaining replication policies, replication status, and health reports. There's also a master target role at the recovery site. That role it acts as a repository for all the replicated data and the change journals as well. And there's also a function that runs on that role called the mobility service that that runs on the master target role. It's a lightweight software component that captures data changes that are being generated on the protected workloads continuously in real time and directly from memory, just for replication purposes. So this is strictly for VMware and physical servers that these additional components are required. All right, so what we've done, I've actually set up a lab, or a demo, I should say, to do the ASR failover. Some of this I actually pre-staged, though, because it can take a few minutes for it to provision within Azure, and just to make sure we stay within our time frame. So we'll kind of walk through this real quick. So this is the Azure Portal, the recovery services on the left there you can see. So first thing we'll do, we'll have to create the new vault. That new vault is going to give us the ability to define where we're going to store our site recoveries. It interfaces with the config server if we deploy one for VMware and physical server protection, as well as the location for the master target servers and process servers. So we've configured a new vault, which we see here. So we say new recovery services, site recovery vault. We're going to quick create this. We need to make sure we put this in a region where we already have storage provisioned. in this example, we use the West US for our demo. Oh, and one thing to note, when you do hit the drop down there, not all of the data centers are listed, so they're not all enabled for ASR at this time. So they're adding new ones all the time. But you'll notice when you go through and create your new vault that not all the data centers are all the regions, I should say, are an option in that drop down. So once our vault has been created, we can now go through the process of setting it up. We have a number of choices here when we're configuring our vaults. So these are the different scenarios we just discussed that are supported. In our case, we're going to be just doing a Hyper-V site and Microsoft Azure. So for our demo, we were just using a single Hyper-V server, no VMM, to replicate out to Azure. And this is a step-by-step process. So we give it a name. Now that we've created the site, we can go back to the recovery services landing page, which we see here. So the next step is going to be to prepare the Hyper-V servers themselves. And this, when you see the landing page here, you'll actually see where it's kind of step-by-step and pretty easy to navigate through. So first step is we're going to download a registration key. They've changed up the certificate options, so we just download this registration key. This is the certificate for the authentication mechanism to allow access to the vault from our protected server. This removes a lot of that complexity we're talking about. These vault credentials should be secured and treated like any other certificate, though, so anyone who has these credentials has the ability to authenticate to your vault. So I'm going to choose first to download the provider. This is going to be my agent, which I need to install on my Hyper-V hosts. I've already done that in our lab here. After the provider is installed in the Hyper-V server, the first option is going to be configure your internet settings. So if the Hyper-V host does not have direct access to the internet, that's fine. You can still set this up with a proxy server. And then this is where I need to browse out to find the key file that I've downloaded. It inputs our necessary information for connectivity, which we see there. And then clicking next is going to verify that the server was successfully registered. So this next step is going to be to create a storage account, and this is going to specify where we put our replicas. So this is required because while the cloud metadata for protecting the VMs is sent to ASR, like we discussed, the actual data actually lives in Azure storage. So I can put this in my affinity group, or I can specify a location. And lastly, my replication is geo-redundant for this storage. So once completed, it's now my new, it's going to show up in my Azure storage now for my ASR web demo. So ASR is going to provide us with the capability to do a test failover of our protected VMs without impacting our production workloads. So for this step, I'm going to need to create a separate Azure virtual network. We're going to be sure to use an unused IP range. We're going to call it, in this case, the ASR web demo. Yep. And again, this network needs to go into the same Azure region where the SRM vault and the storage are configured. And we'll see, we want to make sure that it's not routable with any other of our Azure VMs, because we are essentially bringing up a server that's potentially the same name in our network environment. We want to make sure that this network is non-routable. So we're not going to add to the site connectivity or to the the site-to-site connectivity or the point-to-site connectivity to make sure that it is isolated from production traffic. And then now that that's complete, we can move back to the portal and see what's next for the deployment. So now we'll create our protection group. This is step 4, create and configure protection group. We'll be prompted to create one since none exist. So we're going to name it. We're going to give it the Hyper-V site, which we've already configured in the portal. We're going to give it the storage account that we created as well. Click next. And so this is where we set our actual Hyper-V replication settings. And what we've found is the more frequent the copies, the greater chance of success. The deltas for those replications are going to be a lot smaller if they're closer together time-wise. Also, how often do we want to take application-consistent snapshots? How long do we want to retain the recovery points for? And, oops, sorry. how long we want to retain those recovery points for. And then this is all kind of similar to how we would set up Hyper-V Replica, if you're familiar with that at all. Kind of some of the same options here. We also include the initial replication start time, so we could choose to start the first replication immediately, or we can choose to start it at night when there's more available bandwidth and less potential to impact production traffic. So this is what I've staged before the webinar here. So what we can do is go ahead and head on over to the Azure Portal and take a look at what's currently set up, and then we'll actually perform a failover test of our test VM here. So we see under Recovery Services, we see our ASR tests. Let me actually click back here. This is our dashboard again. So if we did want to initiate a failover of a recovery plan, or all of our recovery plans, we go to Recovery Plans here. And this is our demo, and we would say, so we have two options. So we have, and each of the options is going to give us kind of a little bit different workflow and how it's going to run the recovery plan. So if we say test failover, we're going to specify a non-routable network. We'll see that in just a minute. It's not going to have any impact to the production machines. If we selected to actually failover, that workflow is going to be a little bit different. It's going to actually shut down your production machine. So we want to make sure we only have one server that's the same server instance on the network at a time. So that workflow is going to be a little bit different. We want to make sure we're only failing over if we truly mean to fail over this VM. So in our case, we'll perform a test failover. We're going to select our virtual network that's not routable. And in our case here, a recovery plan, we didn't really look at it, but except in the slides, but this only contains one VM. Typically, with our recovery plan, we would also want to include a domain controller running DNS, so that if this is a Windows box, when we bring it up and we want to fully test our application, we've got Active Directory and DNS resolution there and available, so that we can test the application, start to finish as much as possible. So for our simplistic test here, we've just got our single VM. Select our non-routable network. And it tells us here test failover is in progress. We've got a little bit of insight into this, so if we go click over to jobs here, you'll see some past jobs that have been done. So this gives us a good history too. So when we, for example, are getting audited, we can say, and they ask what our disaster recovery plans are, we can actually export these jobs, all the details about them, and give that to the auditor and say, here's our plan, and here's the last time we ran it at 9:50 this morning. So that's kind of a nice option. So if we go and we click there, we'll be able to see the actual steps being taken within the plan here. So what it's doing at this point is it's actually provisioning a VM in Azure. So these virtual machines are not used. There's no compute resources that are used within Azure for these protected VMs. We're simply using storage up until the time that we initiate a failover. So at that time, it's going to spin up a virtual machine and then attach the storage to it. This typically takes, for this VM, actually we can go back and look. It really took about 3 minutes really for it to come up. It sat at the waiting to complete for about 32 minutes before we completed that, but it really just takes a few minutes for this to fail over. Any questions while we're waiting? Check the chat window.
If you do have a question at any time, please feel free to put it in the chat window and we'll get to it at the end.
All right, so now that we've started that, I'll actually click back over to the presentation instead of everyone staring at my screen here. So pricing overview. So the pricing is actually per protected VM. Sorry about that. Per protected VM per month. It is free for 31 days. So anybody with an Azure subscription can go out, can go ahead and actually demo ASR on every server in their environment free for 31 days. After that 31 days, it is $54 per instance, protected instance, if you do want to replicate that to Azure. If you do want to protect to a customer-owned site, to your own site, a DR site, then it's $16 per protected instance per month. And that does include 100 gigs of storage. So your first 100 gigs is free along with that license. And like we discussed, there's no compute charges during protection. We're simply paying for storage. Anything beyond the 100 gigs for that VM is what we pay for until we actually initiate a failover. And at that time we start, when the VM is provisioned, is when we start having to pay compute charges for that VM. So there's more details on the pricing. Oops. Here, trigger on that mouse wheel. So there's more details on the pricing here. And they also have a calculator, which is pretty cool. So you can go out, put in the details of your VMs, storage, compute details about the VMs, and it'll actually calculate out your estimated monthly costs for ASR only. That doesn't calculate necessarily the storage costs. Let's see, does it? It might. We might have to take a look at that. But it doesn't also calculate any of the VM compute charges because of course you're not getting charged those until we failover. See how we're doing on our failover here. Okay, so we have actually provisioned this VM in Azure. Oops. Actually provisioned this VM in Azure. If we go over to our virtual machines, here it is right here. So that's pretty easy. It is starting right now. One thing I would add is this is not a one at a time start, right? So when we put all of our VMs into the recovery plan, these would actually be spinning up as many VMs as we include into that first phase of the recovery plan. So we could start up literally 1,000 VMs here if we wanted to, if we had a total failover. So the time to failover isn't start to finish. When you start one VM, then it starts the next one. It does start them all at the same time, the ones that are included in the same groupings within the recovery plan. All right, so it is running. We should be able to hopefully connect. So it does give us pretty granular insight here. You'll see there it does group VMs, so we can group our VMs based on dependencies. So group 1 is always going to contain our Active Directory domain controller, or typically. Group 2 would then include, your next tier and your application sets. So let's say your SQL servers typically be included in Group 2, and then past that would be web servers, application servers, things like that, so that we're coming up in an orchestrated fashion. Another thing we didn't discuss too much, but we can, when we're setting up the VM, we can specify a different IP address to use that's going to, so once it fails over into that isolated network or to an Azure network, it'll actually re-IP the VM. We can give it a new DNS server as well. So it'll actually come up with a valid IP address and that network range. It'll specify whatever DNS server we want that will be on the recovered network as well. So it'll update its DNS entry and hopefully minimal impact to applications as we fail over these workloads. So we can see here we have completed testing. So we started that VM. Start to finish, we had a fire in our building, whatever. It took about 2 minutes to bring that up. If we go and look now, let's refresh this. Not giving me the option to connect. Well, for some reason I'm not able to connect, but if I was, we'd be able to connect to this and actually just see the console on the VM really is all we're going to be able to show here, just that it's up. And we could show its IP address, etc., but no applications really running on there. So once we get to this point, though, we should be able to connect to any or all of our VMs that are in our isolated environments fully test our applications, make sure our DR planning is looking good in the recovery as well, validate that everything looks good, no problems with applications. And then when we're done, we go back to our job here and we just say complete test. So completing test is going to reset our environment back to the pre-test state. So it's going to remove, say test complete. It's going to remove that VM, deprovision it in Azure. We'll see that go away here. And basically return us back to our pre-test state. So for production failovers, very similar, except with the difference that it would shut down the source VMs first. We do have the option, once we do fail out to Azure, we do have the option to fail back to on-premise when it's appropriate. We didn't go through those workflows today, but just know it is available. And that will be it. So once we're done, we can see here, like I said, we can go back and look at, so this one, for example, failed on the 4th. This is our ASR web demo. Let's see the details of it, sorry. Yeah, here we go. So look at the error on that detail, and looks like I already had a test failover that was in progress when I tried to test the failover again. So we can't do that, we have to run them one at a time. So I'd forgotten to clean up the test failover before. After I cleaned it up, I was able to go and successfully run the test after that. So pretty good logging here as well. All right, so that's our pricing. So as we've seen, ASR is going to meet most or all of our DR goals that we discussed earlier. It does simplify our DR moves. It improves our RPO and RTO for outages. It allows for our non-impactful DR failover testing. It also allows for application consistent recovery points, which is important. It's flexible so that we can protect those heterogeneous environments that most of us own. And we can also fail over to both public as well as private infrastructures. So came up a little bit shy on the timing. So we have plenty of time for questions. Does anybody have any questions here at the end? Okay, can Generation 2 VMs be protected to Azure? Yes, this functionality is pretty new. I think it came out in June or so. ASR can protect Gen 2 VMs. What it's going to do, it's actually going to convert the VM to a Gen 1 during the failover to Azure Cloud. And then likewise, when you're going to do the failback of that VM, it'll convert that Gen 1 VM back to a Generation 2 VM during the failback procedures. That's a cool new feature. Let's see, is an offline seed initial replication possible? No, that's not possible at this time. I'm assuming you mean like using some sort of transportable media to copy your VMs to, and then ship that off to Azure and do your initial seeding in that fashion. That is not possible at this time. I've not seen that on the roadmap as of yet, but I wouldn't be surprised to see that sometime in the future. Any other questions from anybody? All right. So thanks again for attending.
This will be recorded, or it has been recorded, and I'll be sending it out to everybody from our YouTube page. So if you can look out for that. And I think that's it. So we appreciate you joining us today, and hope you have a good rest of your day and a good rest of the end of 2015. Thanks, Joe.
All right. Thanks, everyone.
The leader has disconnected. The conference will be terminated.